You all got better and better. I saw your confidence growing as you worked on line plots. We will have one line plot on the second half of our math test on Friday. So let's just refresh our memory on how to do a line plot. I won't go through every data point here. I'll just remind you of how to do this work. That way you'll again feel confident for our test question on Friday. Remember that this week Coach Doherty is doing a fun field day virtually with you all. So go check that out on her page in your courses on Schoology, and you can participate and ask questions at her 3 to 4 o'clock help session each day as well. Here goes. The award ribbons have arrived for field day. However, Miss Doherty has discovered that they are not well made and are inconsistent lengths. The table, right here, shows the lengths of the ribbons she has taken from the box and measured so far. I like to pause there and just see what is on the page. Here I understand the chart has the ribbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 ribbons, and it shows their lengths. When I look at the lengths, I notice that they have mixed numbers. That means there's a whole number and a fraction. And I also notice that the fractions do not all have the same denominator yet. So that's something I'll consider as I'm filling in my line plot. Let's go back to the story. Complete the line plot below to display the information shown in the chart. Be sure to finish labeling all of the marks along the line before you plot the data points. Excellent, so now I see two of my tasks. 1, I need to make sure I complete the line plot. 2, I have to make sure that I label everything. And I don't want to miss number 3 down here. Here's where a question comes in about my line plot. I would start at step 1, making sure that I complete this line plot. To do that, I want to note that all of the markings are in eighths of an inch. Here I see my measurement is in inches. And since the denominator along the line is an eighth, I can see that they moved from 4 inches to 4 1/8. Then I have to label this one, moves to 4 3/8, 4 4/8. So the missing number here would be 4 2/8 because I'm counting by 1/8 increments. 4 2/8, 4 3/8, 4 4/8. What would come next? Good. 4 5/8. And I would continue along. Again, I said I'm not going to complete the whole problem, but just remind you of how to do it. I would go ahead and label the entire line plot before I charted my data. Remember to chart your data. Every ribbon is going to get its own X on the line plot. In this case, I'm looking for where to put 4 1/4. I'd come over here and I would immediately notice that 4 1/4 isn't listed like that. Instead, I need to come up with an equivalent fraction. Remember, everything on my line plot is in eighths. So I need to figure out how to write 1/2 as something eighths. Many of you have this memorized, that half of something, like half of 8, is 4. So you know that you'd go to 4 4/8 and draw an X for that piece of data. If you're not sure though, just give yourself some scratch room. You can draw a picture if you'd like and say, I have 4 1/2. If I'm supposed to have this in eighths, I need to slice up my data here into 8 pieces. That would be 4 pieces, and then I have 8 equal pieces. How many pieces are colored in? 1, 2, 3, 4 of the 8 pieces. So I just showed myself that 1/2 can be converted to or shown as an equivalent fraction with 4/8. Another way to show this would be to use your equivalent fraction conversion of multiplication. How do I go from 2 over to 8? That I multiplied by 4 to make that increase. How do I then go from 1 to 4? You also need to multiply the top and the bottom by the same number when you're making an equivalent fraction. So I'd multiply the top by 4 as well. 1 times 4 is 4. 2 times 4 is 8. I've made an equivalent fraction by multiplying the numerator and the denominator by the same number. You would continue plotting your points for every piece on the chart. Remember, you can check your work by knowing that you should have 11 data points, and that means you should have 11 x's here on the chart. If we did one more example, let's choose this one here. We would show where 5 3/4 needs to go on our chart. Notice again, 5 3/4 does not have the denominator I need. Everything on our chart is in eighths. So let's do one more equivalent fraction. The 5 will remain a 5 whole things. Then I need to know 3/4 can be said as how many eighths. So let's do 3/4 equals how many eighths? How do I get from 4 to 8? Well, I multiplied by 2. In order to find an equivalent fraction, I need to multiply the denominator and the numerator by the same thing. So since we used times 2 to get to 8 as our denominator, we'll need to use times 2 at the top to change our numerator, 3 times 2, into a 6. So now I have a data point that I can include on the line plot because its denominator matches my scale. 5 6/8. Remember, here's 5 1/8, 5 2/8, 5 3/8, 4/8, 5/8, 6/8. This would be where 5 6/8 goes. Remember, you will have already labeled everything on your line plot before you start tracking the data, because that's what it says to do here. Label the line plot and chart all the data, and then you have one question at the bottom. After your line plot's all labeled and all of your x's are put on, it says, what is the difference in length? Difference, that's telling me what operation to do. What is the difference in length between the shortest and the longest ribbon Miss Doherty has found? Show your work. Okay, I want to make sure I do that for sure. And to find the difference, I'll be subtracting. And it's the difference between the shortest, whatever ribbon ends up as an X on the far end here, the minimum side of our scale, and the longest ribbon, whichever ribbon is the maximum length. Looking at this data, I actually can already tell that this is the longest ribbon right here, 5 6/8. And I'm just going to show you how to do a subtraction problem to refresh your memory with fractions. I can also look over the data, even though I haven't plotted it all yet, just as a little sneaky. Right here, this is the shortest ribbon in our example. This would be 4 1/8 would go there. This is my minimum. This one here, I know is my maximum, just because I've already looked at the chart in advance. And when it asks for the difference between the longest and shortest, that's the same as the range. So I know I'm finding the range of this data. Oof, messy writing. So to find a difference, 5 6/8 minus 4 1/8. Remember, with our fractions, you can often subtract just the whole number, and then you can often subtract just the fraction part. That's the case for this example. You could also draw it out to help you. You could draw 5 whole things and 6/8, and you could draw 4 whole circles and 1/8, and use those to help you subtract. This is just a quick refresher. What is 5 minus 4? Well, that's 1. I'd have 1 whole thing left. If I have 5 ribbons and I take away 4, for example. And then 6/8 minus 1/8. If I have 6 of something and I take away one of them, then I'm left with 5 of the eighths. 5 and 6/8 minus 4 and 1/8 is 5 and 5/8. That's the difference between the shortest and the longest ribbon, and we're measuring that in inches. I wanted to make sure I included my units and I showed my work. Your work could include a picture, of course, as well. All right, you are going to do a great job on your test. You have had 3 days of line plots last week, and this was just a quick refresher. Make sure you follow each step on your test. You would have filled in all of the data, all of the scale, I should say, down at the bottom. Then you would include all of your data with those X's, making sure you find the equivalent fractions when needed. And then you'd answer the final question, showing your work. I can't wait to see all of your great thinking.